on natural flood management. So over to you, Alistair.
Thank you, David. I've got an hour booked in for this slot, but I'm hoping I won't be talking for an hour. I've got a couple of videos as well, and then I'll probably leave a bit of a section at the end for questions, hopefully. Okay, well, thanks for asking me to talk to your event today. My name is Ali Maxwell. I work for the Environment Agency based in Blandford, and I've been with the agency for nearly 20 years, but in the last 4 or 5 years, my role has been around natural flood management, and I'm the advisor for the Wessex area. It's not a standard role within the EA, although different parts of the EA are kind of approaching it in different ways. But in Wessex, my post is funded through the Wessex Regional Flood and Coastal Committee, and it's a 3 or 4 year so far, and further years to follow. And the aim of the role is to better understand natural flood management, understand what's happening around the country, to support our internal teams and other partner organisations, but also to deliver projects on the ground to kind of test approaches and see how NFM can provide value to our communities and to our environment within Wessex. Okay, so I'm sure everyone on the call has heard of natural flood management, but I thought I'd just give a bit of a background as to what it is. And it's a kind of a moving beast, really. It's a term that can also be, well, there's many other terms that can be used. So I've got a few of those different variations. So it is around working with natural processes. It is about slowing the flow of water through the landscape. It is about kind of catchment and upstream thinking, particularly for communities lower down in the catchment. It's around understanding what's coming from above, particularly from a water point of view. It is around emulating and restoring natural processes and using natural materials to interact with the landscape. But really it's around managing our catchment, looking at our catchment, or understanding what the issues are at communities at a catchment scale and how the catchment can be used to try and mitigate those problems, and particularly around flooding. It's around sustainable use of water and land. For too long, we've, not just in Wessex, but around the country, land use is intensified, and we've become very good, very apt at draining land and moving water as quickly downstream as possible. And natural flood management is around trying to undo some of those approaches, albeit within the constraints of a farming, productive and lived-in landscape. It's not all about giving up what we do in the landscape, but it's about managing landscape in a more sustainable approach. Natural flood management isn't seen to be in isolation. It should be used as a complementary approach to traditional flood risk management. And it will deliver multiple benefits, not just around contributing to flood risk, but also about improving water quality, improving biodiversity, and wider environmental enhancements. It is really around soil structure and soil health and improving the functioning of soils. And therefore, carbon sequestration is a key part of that. And I'm sure that was picked up in the previous talk on climate mitigation. NFM is around lots of small interventions scattered across a catchment, and in working together, the cumulative effects will be greater than any of the individual impacts. But it's not necessarily about building one big reservoir at the bottom of a valley. We've got a few examples of those that have been delivered historically. Natural flood management isn't around that. And also the caveats around natural flood management, it's not going to stop flooding. This is seen as a way of looking at those smaller, recurring, more nuisance flooding events, or at least that's where the evidence is suggesting that NFM has more application. But that field is emerging, and there's a whole range of projects around the country, and I've touched on a bit of that later. But at the moment, NFM is really targeted for small scale, more frequent flooding, as opposed to the big events that probably get more of the coverage, as we've seen over this winter in across the country. I was going to try and show a short video, if this works. Oh, apologies for the advert.
Ali, I'm not sure if we're supposed to have sound for the video. We can't hear anything.
Oh, can you hear sound now?
Nothing now. What you may have to do is reshare your screen, but just click enable sound.
There's no commentary as such. It's just music, so okay. It's more of a visual. I could talk over it. So this is just a neat cartoon kind of video just to show the principles around natural flood management, work in natural processes, and how that applies to improving our communities. Yeah, sorry about lack of sound. Okay, I'm going to pause that one there and get back to the presentation. There we go. Yeah, so sorry for the lack of sound there. It was just a bit of an instrumental. But I think the ideas there were probably quite clear that what natural flow management is about is restoring natural processes and giving space for water throughout the catchment. I've got a little graphic here. I've already touched on a few terms that have kind of already been interchangeably used. It does show the relationship here between these terms, work in natural processes, nature-based solutions, and natural flood management. And it's really around what the measures are specifically designed to deliver. And for natural flood management, it's principally around flood. But those same measures, whether it's leaky dams or improved land management, could deliver wider environmental benefits as well, such as water quality. I find this really quite useful in understanding that. Okay, so I'm going to talk through a model around how water interacts with the landscape, and this is called the source pathway receptor, and is often used by Natural England's catchment sensitive farming officers when talking to land managers around how they could manage their land more sustainably. And it starts off with the source, and basically this is where the moment water lands on the ground, it interacts with the soil and the plants and vegetation. But if there are issues with how the land is managed, whether it's the wrong type of crop or there's compaction caused by farm machinery or livestock, then that water won't have the ability to infiltrate into the soil as naturally as you would expect or is needed. And because the water can't infiltrate, it runs off, and that can be either on the surface of the field or the subsurface, and that causes erosion, as you can see, gullying in the field there, and that also leads to soil erosion. To try and remedy some of that, you've got land and soil management kind of practices or approaches. Subsoiling is the key, and that helps break up any compaction layer and allows that water to infiltrate and reducing that surface water runoff. But there are more kind of natural approaches as well, and you can use what we term cover cropping, and that's often used when maize is grown and allows a grass or a vegetation layer to grow up in between the maize crop. But also an approach called herbal layers is very often used as well, and this is where plants with differing root lengths are grown in between crops or in between different rotations, and those differing roots allow the breakup of that compacted layer and allow that water to infiltrate. And those herbal layers also provide pollination benefits because of the flowers. They improve soil structure and soil function as well. So there's actually a productivity benefit for the farmers as well. It also allows water to get into the aquifer, so there's a groundwater recharge benefit as well. Next part of the model is about the pathway. So you could do all your compaction and allowing infiltration as you can, but sometimes runoff will still occur, and this is where water flows off the land and gets onto our infrastructure, so such as roads or ditches or other pathways. And as you can see by these photos, it's not just water, it's the soil as well, and that soil often ends up in the gullies, often ends up in the ditches and streams. And from a highways maintenance point of view, it adds extra cost and extra maintenance requirements. And I've got a live video here. Just an example of runoff from one field going across the road and then straight onto another field. And this kind of runoff shouldn't be happening, particularly in some of the groundwater catchments we have in Dorset, where you've got really permeable soils. So that's an example of where there's a real issue with land management, with compaction. Some of the measures to intercept those flow paths, it's relatively straightforward, really. You design a feature such as a pond or a wetland or a sediment trap that holds water on that flow path. So you stop and slow that water moving along that flow path as quickly as it would do. It also holds back some of the sediment. You can see that photo in the middle. This is all sediment that's been retained within the field edge using that barrier. This is the farmer's profit. You know, the soil is what is used to grow crops, so it's imperative for landowners to visualize how much soil does come off. So this is a really good technique to do that. You don't want these ponding features to hold water permanently, because then there's no capacity for the next rainfall event. So they're leaky ponds, and they allow water to dissipate either into the ground or through an offtake more slowly until the next rainfall event. And they can provide other benefits as well, such as kind of wetlands creation and green corridors. Tree planting and hedge planting covers both of those first parts of the model, both the source and the pathway. Trees have been talked about in the previous talk from a carbon point of view, but they are fantastic at intercepting rainfall even before it hits the ground within their leaves and branches. And also their roots allow water to infiltrate into the ground as well. So trees and a great tool for natural flood management. They can be planted in particular locations to intercept a flow pathway or across a field slope, and that can again slow up the movement of water through the landscape. And same with hedges, particularly if they're managed in the old traditional way of laying, and then it provides a physical structure on the ground. So these are really good tools and techniques, and provides, as we know with trees, many other benefits as well in terms of biodiversity. Again, green corridors connecting up pockets of woodland, allowing you know, the species, insects and mammals to move through the landscape. They also provide good windbreaks, so provide actual tangible benefits for livestock farmers as well, particularly on the headlands and higher ground, and provide beneficial pest predators as well. So there's some real good productivity benefits for the farming community as well. Another measure on the pathway part of the model, and this is around once the water's got into the stream or into the river, and this is where probably some of the more classic NFM measures kind of arise, and this is around installing what we call leaky woody structures or large wood, and the aim of this is to intercept or slow the movement of water through that channel, but it also provides really good habitat, in-channel habitat for fish and vertebrates. We're looking to emulate how a tree would look if it fell into the stream and not completely block up. I've seen some horrendous photos of almost machined wood walls installed in channels. They provide the function, but they don't provide the other benefits, and they're kind of working almost against those natural processes. And the big one really is reconnecting rivers and floodplains. This is a key kind of demonstrable benefit for reducing flood risk. Historically, rivers have been straightened, they've been embanked, and the idea is to get water downstream as quickly as possible, similar to what that video was showing. By reconnecting rivers and floodplains, reducing those embankments and getting more water from the floodplain, it slows the time, delays the time, and delays the peak, whereby water will reach communities further downstream. This obviously has a big impact on managed land, farmland. So landowners, farmers need to be part of any conversations generally about NFM, but particularly about reconnecting floodplains. And there are changing farm subsidies following Brexit, and there will be payments for, in theory, there will be payments in the near future for farmers to hold more water on their land, although the details for these payments are still being discussed at DEFRA. But the principle is, you know, their land is providing a benefit to society by holding and storing water, and those landowners should be paid in some form for that benefit. Obviously, a range of other benefits for connected floodplains and is around primarily the habitat, but also water quality and the carbon sequestration benefit of wetlands and the sedimentation that's deposited on the floodplains during flood events. So the final part of the receptor is kind of where the flooding happens. This doesn't necessarily have to be at the bottom of the catchment. It could be anywhere where water holds and causes an impact, and that can be the road network. It could be a small village or a town where there's flooding, even on farm infrastructure. I've included that example there because flooding of a farmyard in that way would bring a lot more pollution issues into the watercourse as well. And it's not just about the flooding, it's about the water quality within the receptors, and particularly in Dorset we've got Poole Harbour that's experiencing high nutrient levels, and a lot of that is coming, not all, but a lot of that is coming from field runoff, and the nutrients that are applied for growing crops comes off with the soil that ends up ultimately into the Poole Harbour and leads to algal blooms. So by delivering measures to reduce that runoff, reduce that sediment getting into the watercourse, there is a flood risk, there's a water quality benefit to Poole Harbour as well. Okay, I've got a tiny bit of science here. This is a standard hydrograph, and it shows the river response to rainfall, and and you can see the red line rises as the rain's fallen, and that line above the dotted blue line is where that flooding occurs, and that's the peak of the flood curve, and that's where the flooding occurs, and that's causing obviously problems to the community. What NFM is trying to do is reduce and delay that peak, so you've got the same amount of water, but it's actually in terms of the impact of the river, the level of the river is lower, and there's no flooding occurring. This is the theory. It's very challenging and difficult to demonstrate actually what impact NFM measures have on the hydrograph. There are a few examples, and I've touched on that shortly, but this is a theoretical kind of explanation. So what are the EA, or what have the EA been doing around natural flood management? Okay, so nationally, following the floods of 2015-16, particularly in Cumbria, I think some in Somerset levels as well, the Working with Natural Processes evidence directory was compiled, and this is the first time that all the known evidence and data and literature that's been created around natural flood management was compiled in one place. NFM didn't start at 2015. It's been delivered and talked about for many years before, sometimes with different phraseology such as river restoration or water management. But this is the first time it's kind of compiled in one place and used as a repository for practitioners and communities to be aware of. And it compiled a literature review looking at all the scientific papers, the directory of evidence and data, a whole range of one-page summaries on the key measures. You probably won't be able to pick up the labels on the catchment map there. There was also around 65 case studies that were included as part of that review, and these range from river restoration projects to moorland grip blocking and coastal NFM as well. The project also delivered a range of opportunity mapping GIS layers covering tree planting, runoff attenuation and floodplain reconnection, and they give a really good grounding both at the catchment level for practitioners to start building up the idea of a potential project. And this is just a example of one of the one-page summaries. It just gives a background as to the information within that evidence directory. And I can share links for this outside of this presentation. Now I do have another video, but based on the previous, this may not work. I'm going to give it a go, and then we'll see. It'll be a shame if this one doesn't work, because it's really good. Now, can you hear that?
No, not at the moment.
Okay.
Ali, there is a way to resolve it. If you unshare your screen and then you share again, but before you click share, you've got the option then to include sound.
Okay.
So if you hover over the share screen icon or share content.
Yes, I got you.
You've then got include sound. If you click that, it should then enable you to play videos through YouTube and have the audio.
Well, fingers crossed.
That's better. Yep.
Perfect. Enjoy. This is about 6 minutes.
In the 1990s, a small group of sheep farmers in central Wales began planting trees. Their intention was to create shelter belts for their herds and to adopt a more sustainable approach to farming. However, as the trees grew, the farmers soon noticed how these shelter belts reduced the runoff of water in heavy rain. Inadvertently, they had stumbled upon an upper catchment way of reducing the intensity of floods. Since then, these farms have become home to some groundbreaking research, and the use of trees as a flood mitigation tool has spread far across the UK.
Trees have a really valuable role in helping to reduce flood risk. Their roots go down into the ground, helping to break up the clay so that the water can infiltrate down into the ground instead of just flowing off the surface. Within a year, all this grass in the field, keeping the sheep off, it will be much rougher, so that when you do get a heavy rainfall event, it's got to filter its way down all through that grass and take longer to get down into the valley bottom. It's all about slowing the flow.
This idea of slowing the flow can take form in many different ways, from tree planting to small leaky dams, attenuation ponds, and even the structure of the soil itself. But the principle remains the same: hold the water upstream to cushion the impact of a flood. When floods occur, rain falls and waters rise up to a point at which it's most severe. This is the flood peak. By slowing the flow of water through a river system, we can take the top off this curve, reducing the severity of the flood. That's the basic principle anyway. But in some places, the understanding goes far deeper.
One of the key things that maybe marks out this project is the fact that from the very beginning we went to try and collect real hard data on the ground. This is probably one of the most monitored catchments in the United Kingdom in terms of the flood levels. We've got all these gauges all the way up and down, and we can isolate out each little sub-catchment as to what's happening and track a rainstorm as it goes down. So it means that people can come and test their models on our data. It's very powerful.
When implemented strategically, these natural flood risk management ideas can be a strong complement to traditional engineering. Models are an ideal way forward, but they do take time to establish, and there are always greater considerations, from the needs of communities to those of landowners to national and local authorities. In many instances, collaboration can be the only way forward.
I've made it my job to go and become really intimately familiar with our whole catchment. So rather than relying upon models to tell me where to build stuff, I've come out and I've found places that I think we could do good work. But more importantly, we've found places where there are landowners who are happy for us to do any work, and momentum grows. You don't need a shower of cash all at once to install and build a lot of natural flood management.
Agriculture is one of the biggest land uses across the UK and is also home to one of our greatest and most degraded resources, the soil. While healthy soil can help store water whilst nurturing agriculture, compacted soil does the opposite, struggling to hold on to rainwater and easily washed away in high water flow. Many farmers around the UK are already adapting their practices to try to improve the health of their soils, and even small changes over such a vast area can make a powerful difference. Further upstream, vast peat moorlands roll through the UK. Healthy peatlands store huge amounts of water and also help to sequester carbon from the atmosphere, helping to mitigate the impacts of climate change. Anything that we can do to help reduce the severity of climate change will have a direct effect on the severity of floods that we will be seeing even in the near future. But in the UK's peatlands, we can have a significant impact on flooding even more immediately.
I'm sat on a heather bale, which is trying to block a drain or a grip that was cut into the fell. We've come full circle and we're blocking them up to raise the water table and try and get a functioning blanket bog back. Why is it better wetter? Functioning peatland or blanket bog requires a water table within the first sort of 5 to 10 centimetres of the surface. You've got a healthy functioning bog, water takes much longer to flow from here down to the river than it would if there was nothing on here.
Sphagnum regeneration techniques are now proving that it's more than possible to restore healthy blanket bog to peatlands whilst simultaneously supporting carbon sequestration, hydrology, biodiversity, grouse management, and even sheep. Our relationship with the environment is changing as we discover the services that ecosystems truly provide. Floods may continue to wash through our lives, but our knowledge of them and our response to them is changing. Now, in our approach to flood risk management, we have the opportunity to satisfy economy, biodiversity, climate, agriculture, hydrology, and community. Now, from high waters, we can find common ground.
That's it's a really good good film now, but it's only a short part of a longer version. But it does demonstrate the multiple benefits that NFM can deliver, and particularly on that climate agenda, which I've also picked up in the previous talk. Okay, so DEFRA about 4 years ago provided £15 million as part of the DEFRA NFM programme, and this was to better understand NFM, deliver a whole range of projects, achieve some outcomes in terms of reduced flood risk and habitat improvement, but also plug some of the gaps that the evidence directory had highlighted in terms of knowledge and research and development. It was broken down into, I think, probably about 30 catchment scale projects. We had one in Wessex over in Somerset, and also around 30 smaller scale community projects. And we had one successfully attracting funding in Dorset, and that was on the Piddle headwaters. And I'm just going to spend the next few slides just talking a bit more detail around that project. So the Piddle, as probably most of you know, is a tributary of one of the Poole Harbour rivers. And the project focused in the headwaters, upstream of Piddle Trentide, around the villages of Alter Pancras and Plush, but really looking at the headwaters of that river system. And the Piddle is a chalk stream. It's a groundwater dominated catchment. The headwaters are steep slopes with dry valley coombes, with a mixture of intensive arable and dairy farming, just to give a bit of background to the catchment. The project was led by Dorset Council as part of the fund, and worked really closely with Natural England's Catchment Sensitive Farming and Farming Wildlife Advisory Group to engage and deliver measures on the ground. The aim of the project was to see how NFM and working with natural processes could lead to a more sustainable catchment management in these headwaters and reduce some of the water-related issues, particularly surface water runoff that the communities and the villages downstream were experiencing. So some of those issues highlighted in the photos here. We've got dry valley coombes that turn into raging torrents. We've got field runoff bringing all the soils into what should be crystal clear chalk stream water. We've got villages with rain pouring through the road system. We've got a lot of tracks down these steep slopes, and the tracks, when there's heavy rainfall, they erode, and a lot of that material ends up in the road systems and blocking the gullies. And you can just see that photo with the welly, how deep some of these gullies appear. And I've got a short video here just showing an example of a ditch that's full of water during a rainfall event and then crossing over the field. And this is just an example in one field in the headwaters, but there's numerous examples of this across the catchment. So it does kind of demonstrate the scale of the problem. And it's just a summary of some of the issues perceived in the catchment. So the approach was to better understanding the role of farmers and landowners is important, not just highlighting the issues with current land management practices, but listening to what the farmers know and how they might address the issues. And in this way, a farmer group was established with catchment sensitive farming playing a key role. The CSF officer had been active in the catchment for many years and built up relationships and trust with the farming community. So it made it much easier to engage and highlight some of the issues and talk to them about what they might do or how they might be able to address some of those runoff issues. We found it really useful showing maps. It might seem a simple thing, but farmers know their land very well, but they understand it where their land boundaries are, not necessarily where water flows. So showing a map with flow paths and where water flows is quite an eye-opener, and it does naturally engender cross kind of boundary discussions with their neighbours, which is really useful. Some of the measures, won't go into too many details, but we've got examples there of woodland management and leaky dam being installed. We've got ponds, we've got bunded field corners with hedges, and I've got a short video here of a typical example of track runoff. Ooh. Sorry, track runoff during a rainfall event with all the material from the track. This was going onto a road, directly onto a road, but instead we put it through a sediment trap, which was designed in a way that the farmer could easily maintain, and then that overspilled into more of a wildlife pond. And that's, go back one, that's just a good example, or a wonderful example of how the tracks can be managed in different ways. It's very difficult to stop all runoff, but the water that's generated can be managed. And here are some of the other features that have been planned or delivered. It was a good example of how you can have all the best opportunity mapping or where we think measures should be delivered, but it's not until you work with the farmers and gain agreement, and ultimately they need to give permission to allow the work to be delivered, but also to maintain any measures as well. Otherwise, the effectiveness will decline over time. So having landowners and farmers on board is really key to any project like this. But there's also a good example of showing the two community groups, effectively the village community and the farming community, understanding the role that each play in assessing and addressing the issues. So that was funded through DEFRA's NFM programme, and alongside my post, I have a bit of money to deliver projects on the ground, and this is just a snapshot of the Wessex NFM programme, and you can see there's a number of projects funded in Dorset in blue, and I'm just going to talk a little bit about some of these projects, but I appreciate time is marching on, so I won't go into too much detail. So this example is on the Hook, which is a tributary of the Frome in West Dorset, and similar to the Piddle, it's in the headwaters. It's steep sloped. It's quite intensive land use, but it is a quite fast responding river, so there's a lot of soil erosion risk as well. And this is a project led by Dorset Wildlife Trust to better understand how land management and the landscape interacts, to reduce the impacts of rain and runoff and improve resilience for the farming community. So a few photos of some of the issues, very similar to the Piddle. It's around erosion of tracks, erosion of bare ground or arable ground. But the photo at the bottom there, that kind of white area in the green field, that is all sediment that's been eroded further up in the fields, and this is quite big gravel. It's not just fine sands and silts, these are big gravels here. So it just shows you how much erosion can occur, and this would ultimately end up in the road and gully system, if not the river. Some of the wider issues. So the approach here was to provide technical evidence of the catchment processes to the farmers and land managers, such as how flow paths, tracks and roads connect to their fields and to watercourses. So a fluvial audit was undertaken, and that gave us better understanding of what was going on, and we could describe that to the farmers. We set up a number of breakfast meetings, and I've got a picture of a bacon sandwich, and I don't mean this glibly, but it's a really good way of getting people to come to a meeting and talk about things that may not be high on their agenda or high on their priority list, but it starts that kind of dialogue, and it proved really successful for the project. This is just an example of some of the outputs from the fluvial audit and identifying issues and opportunities. And we use this as a way to engage with the farming group to show on the ground what could be delivered on their fields. And in terms of measures, we did actually find some good functioning habitat, and the top two photos are examples of good existing wood, natural wood in rivers, and we use that as a good example to reference where we might install wood, what it might look like. Examples of bunds in fields to hold water. This flow path used to go straight through the gate and into the road. This bund now holds that water and stops that road from flooding and getting the soil and silt on it. This one doesn't show so clearly, but it's a bunded field over periods of time and showing how much silt is accumulating in the course of a year. This will require maintenance, and the farmer is fully on board with that. And it does demonstrate again how much soil they're losing. There's a few other measures we delivered as well. Okay, so I've got a few other projects, won't go into many details, but this is the River Asker, West Dorset, flows into Bridport. And this is the Dorset AONB have been working extensively with the communities in this area, and the funds I had kind of added to their work programme and made their efforts go further. And they've done a lot of things, including experimenting with different herbal lays. They've planted hedges across slopes to intercept any flow paths. They put woody debris in flow paths within woodlands. But they've done a huge amount of effort engaging with the community, and they've hosted quite a few public events, not just talking about NFM, but showing how it's part of a wider range of measures and benefits. I think that project is probably still active. I think they're sourcing additional funds from the EA, more from an environmental emphasis, but still giving that that flood benefit as well. This is a project, Holt Heath in Dorset, upstream of West Moors. It's owned and managed by the National Trust. The heath and mire have been heavily drained historically, so it wasn't acting as a sponge as it should in terms of holding water. So the project effectively blocked in a lot of the key drainage ditches and raised the water table, allowed sphagnum moss to grow and develop, and huge environmental benefits for this. You know, it's quite a rare habitat, loads of whole range of endangered protected species that this project is now supporting. But ultimately, West Moors downstream will benefit from this, and expanded work in the future will benefit there as well. Mottcombe Stream, upstream of Mottcombe, no delivery occurred, but a catchment walkover was undertaken, which has now proved quite important because I think Mottcombe suffered quite significant flooding in the October storms last year. So there's some good understanding of what could be delivered to complement any more traditional approaches around the village. We did a piece of mapping, GIS mapping, trying to better understand opportunities or theoretically understand opportunities where we might reconnect floodplains more naturally. It's a tool that we can use in different projects or to discuss opportunities with landowners. So this is the Dorset style catchment on the left, and the zoomed in photo image is just upstream of Wimborne, the Stour and the South Winterbourne coming in as a tributary, and you can see all the red bits of where there may be opportunities or where the river has been modified in such a way that it's currently disconnected, and that could be through been over deepened through dredging, or where embankments may have been installed. A lot of the work that both the DEFRA programme and the local NFM programme have delivered and lessons learned. I'm trying to pick those up and use them to support the larger EA flood risk programme that we develop, that we manage, and these are just a couple of the projects that we're working on currently. So this is the Upper Yeo and Wriggle, parts of it in Dorset, parts of it in Somerset, but the community in Chetnall on the River Wriggle has experienced repeated flooding over the last number of years, and we feel NFM could play a good role in contributing to reducing that risk. Not stopping altogether, but work, playing a part. And we're also trialing a top-down kind of modelling approach called the NFM Studio tool, which helps identify opportunities both at catchment-wide and field scales for NFM opportunities, while also providing some hydrological numbers in terms of the benefit. And if this tool is successful, it will be rolled out across the rest of the area to support future work. So that's quite exciting. Another project, again, the lowest hour, overlaps that stage 0 slide I showed you. And the idea here is using hydrological modelling to demonstrate restoration of floodplain reconnection and what benefit that might provide with communities downstream, principally at Wimborne. But it's a live kind of project. We haven't delivered any outputs yet, so we'll see if the approach works. But it's a new approach for the area in terms of trying to model and have actual numbers to the benefit. And I think I've only got a couple more slides. Okay, so on the capital programme again, Puddletown is one of the projects that we're looking at, and this is a continuation of the Puddle Headwaters project funded through the DEFRA fund, and it's using the relationships that have been developed, picking up lessons learned, and kind of rolling out the delivery across a wider part of the catchment to see if there's benefit to more of the communities within the valley, but also to Puddletown itself. So that's another live and ongoing project. I think this is my final slide. We're also in conversations with Dorset Council and FWAG to see how we might better address some of the surface water and land management issues that appeared during the recent flooding in October. I'm sure you'll all remember the intense rainfall we had during that time, and it did lead to quite a lot of communities being affected. And we feel that NFM could play quite a role in better understanding and addressing their risk and providing increased resilience. So that's early stages, but in discussions. So I think that's all for me. I know there's a lot to take on. There's a lot of slides there, but I hope everyone found it useful. I'll be happy to answer questions either now or outside of this. And I've got a few links there for some of the resources I referred to. So that's me. I think I've just gone over my time limit. So apologies for that, and thank you.
That's right, Alistair. It's very interesting. I'm fascinated by what people are now doing to reduce, runoff onto roads and all the rest of it, which seems to occur an awful lot, especially when we get the very intense rainfall that we seem to be experiencing these days as a matter, I guess, of climate change. I'll throw it open to the floor. If there's anyone who has any questions to ask Alistair, please put your hand up. Yes, there is one person. Sandra Harry.
There we are. I'm saying on the false pretenses, my name is Tim Culver-James. I work for Tisbury Parish Council. Sandra's my boss. Lucky girl, she's away in Cornwall. I was fascinated by what Alistair had to say about leaky wooden debris. You might be aware that we've got a number of residents here in Tisbury as a result from the flooding of the 21st and the 28th last year, who are concerned about trees in the river.
Yep.
I'm guessing from what you're saying, they're not necessarily a bad thing.
I think on any topic with the NFM, there's no easy or yes or no answer. From a habitat point of view, wood is great in rivers. From a flood point of view, the smaller the stream, the better. I think putting wood or trees in the bigger streams, particularly those with high energy, will have very little flood benefit. And if they're not installed robustly, they will move and they will cause problems downstream. So I try and steer away from that as a measure.
I'm trying to stay away from it too, but
yeah, and it's about I don't mean to sound glib about this, but it's about the right tree or the right piece of wood in the right location. I wouldn't advocate adding any to the main part of the NADA from a flood point of view. There may be value from a habitat point of view.
Yeah, I think we've got to be done waterfalls, but
yeah, it's got to be done with the extreme kind of in mind. You know, as we know,
I'll shut up. And thank you very much, Steve, for your informative information.
No,
so
it's a good question.
I suspect we might speak in due course. I shouldn't wonder.
Yeah, certainly. Yes.
I'll mute, and there we are. Thank you very much indeed.
Thank you.
Okay, there's another hand up, Celia Williams.
Just one further question about replanting a tree, a single tree. Is there any particular type of tree for just planting a single tree to take up runoff water most efficient to be planted?
I think we'd want native trees. We'd want trees that are appropriate for the landscape. Some trees like wetter ground than others. I think one tree isn't going to have, in all honesty, isn't going to have a huge amount of benefit, but it's probably going to have better benefits in terms of habitat and shade and those things. But again, I can speak to you outside of this in more detail.
Yeah.
Right. Hopefully that answered all the questions. My apologies for that. The doorbell rang. You always get a package delivered just at the wrong time. They just seem to know when it's most inconvenient, don't they? Right. We're going to say thank you very much, Alistair, for that.